Today we're going to be looking at features of functions and specifically domain, range, intercepts, and end behavior. So the first feature we're going to consider is domain. The definition for domain is all possible x values or inputs for which the function is defined. While the definition for range are all possible y values or outputs for which the function is defined. So let's consider the example we have in our graph. If you look at this graph, you will see that these two endpoints look like they just stop abruptly right there. However, that just means that the actual graph paper is ending, not the graph. So I would always recommend imagining or actually drawing arrows to see that the graph keeps going. That should help you determine domain and range a little better. So let's look at the domain in this example. As the definition shows you, domain is all possible x values, which means that I want to look at all my possible values for the graph going left to right. So if we look at the graph, if we look at this arrow, we can see that this arrow is pointing left. It's going slightly to the left forever. And if we look at the other arrow, we see that this arrow is pointing to the right, just slightly, but it is pointing to the right forever. So there's no breaks between my left and right arrow. So if we were to say in just words, we would say that the domain is all real numbers. Now, one way to write that would be in what you're probably used to using, which is set builder notation, and we would say that x is between negative infinity and infinity. Notice the inequality signs do not have an equal to because you can never reach infinity, so you can never be equal to infinity. However, we will not use this notation from here on out. We will use what we call interval notation. With interval notation, you're no longer going to have to use the variable that you are referring to. So you're always going to have to label things when you're writing them in interval notation, like you would write domain and then you would write the interval. So our interval for domain here is from negative infinity to infinity. And we just put comma between our left and our right value. Now, the other part to consider is what do we show with the if we have less than or equal to's. The notation we're going to use instead of just less than is going to be a parentheses. If we were to use a less than or equal to inequality sign, we would use a bracket when it comes to interval notation. Now let's look at the range and practice a little more with our interval notation. Now range is down to up, right? The y values is just like the y-axis, which goes down to up. So our most down point, there's no real point. Both of these arrows point down, so the graph keeps on going down to negative infinity. And then the y value, the highest y value we can achieve is from this point right here, which is 4.813. However, that's an actual point on our graph. Therefore, the y value does eventually equal to that value of 4.813. So we have to put an equal to in our set builder notation. Now, what does this mean in words? It just means that the range is all possible values between negative infinity and 4.813, including 4.813. How would we write that in set interval notation? Well, we take out the variable and we just write the down and the up values with a comma between them. And then we decide if we need parentheses or bracket. Since the graph can never reach negative infinity and we have a less than is here, we just need a parentheses. However, since this is less than or equal to, and the graph can equal 4.813, we put a bracket there. In interval notation, make sure you always use the smaller of the values of your interval first, and the larger value second. And just decide if it's parentheses or bracket based on if that interval includes that value or not. That's it for interval notation and domain and range. Now let's look at intercepts. An x-intercept is where the y value is 0 or where the graph crosses the x-axis. And in this example, we have 4 x-intercepts at -3, -1, 1, and 4, and we're just going to write them out as coordinates with commas between them. When we are working with points, to show a long list of them, we use commas. When we are working with intervals, to show a list of them, we would use a U. And a U would need to be used when your graph has multiple parts to it and there is a break. The definition of a y-intercept is where the x value is 0 and where the graph crosses the y-axis. And since this graph is a function, we have one y-intercept at 0, -1.2. And the last feature of a function we have to consider is end behavior. And the end behavior is related to the ends of your graph, and more specifically, the ends of your graph that have arrows. There's at most going to be 2 arrows on your graph, and therefore you're going to have at most 2 end behaviors. You can also have 1 or no end behavior depending on how many arrows you have. So in this example, we will have 2 end behaviors because there's 2 arrows. And the format we use to write all end behavior is as x approaches infinity, or as x approaches -infinity, comma, y approaches what? And this is what we're going to fill out. So this is a template you can use to answer all of your questions. You may have one, both, or none of these rows depending on how many arrows you have. In this case, we would say as x approaches infinity, y approaches, well, the x approaches infinity, that means as x is going to the right. So that would be this arrow. So as x is going to the right, my y is going down. Therefore, y is approaching -infinity. And then the other arrow would be as x approaches -infinity, y is also going down, so therefore that end behavior is also y goes to -infinity. That is it for the features of functions in this video. Now let's practice one more graph together. What is the domain for this function? Notice I used a hard bracket around the -2 because we have an actual point at x equals -2, and I put the -infinity first because that is the smaller value. The range for this graph is 3 infinity with a bracket around 3 and a parentheses around infinity. Again, there's a bracket around the 3 because there's a closed dot and 3 is included in the graph. How about the x and y intercepts? A function doesn't have to have any, and this one doesn't. How about end behavior? How many end behaviors do you think we should write? Since this graph only has 1 arrow, we're going to write only 1 end behavior. And we would say as x approaches -infinity, since the graph is going to the left, y is approaching infinity because it is going up.